Welcome to Building a Next-Gen Compliance Program. We're going to talk a little bit about machine learning. Just to do a brief introduction here, my name is Tim Mueller with Guidehouse. My role there is to lead our financial services technology practice, and my primary focus is on applying technology and data analytics to financial crime.
Hello, everyone. My name is Jessica Geld. I run the Compliance Data Analytics and Digital Transformation Office at Société Générale for the Americas, with the objective of improving the efficiency and the effectiveness of the overall compliance program, including the different surveillance and monitoring models.
Great. Thanks. So we have a couple of different objectives here today. Jessica and I will be kind of going back and forth and talking about how financial institutions are currently leveraging machine learning. But we want to make this as real for everyone as we can. So we're going to talk about some very specific use cases in KYC, transaction monitoring, and quality assurance, and really talk about what types of benefits financial institutions are actually realizing using machine learning today. We wanted to start here just by talking a little bit about some results from a survey that Guidehouse recently conducted. This was a survey conducted globally across all 6 different regions across the globe. And we got responses from over 350 different compliance professionals. One of the things about this that really stood out, and Jessica and I were both commenting on this when we saw the results, was that KYC and enabling real-time continuous KYC processes was the top respondent, the top concern of where organizations were looking to use artificial intelligence and machine learning to fight financial crime. And the second one here was around dispositioning, sanctions, watch list, and actually those 3 little dots there are where it continues on to talk about transaction monitoring. So we'll kind of come back to this, another question on this survey at the end, but we thought this was kind of interesting and important context as we were talking about this. So because KYC started off at the top of this respondent this response, we thought we'd start off with a use case using KYC as an example.
Yeah, absolutely. So I was hoping to share with everyone some of the real use case we are actually using at Société Générale. We built the financial crime client risk rating model in-house, and to be able to predict accurate client risk rating, which is used in the KYC world. So the traditional way of doing that is to use a standard logistic regression model to predict the client risk rating for financial crime. But now we actually use the SMOT, which is the minority oversampling technique to try to get a very balanced sample, and also we're able to create some data which is not available in the current production database, which is not available in the current the client profile, to make sure our model is more capable to be able to predict some future scenarios, which is not able to be seen in the current production environment. In the meantime, we also use the advanced Bayesian framework to include some of the prior knowledge which is delivered from those risk profiles, which is not currently available in the production environment, to be able to get a more accurate measure. And in addition to that, some of the resampling techniques have been used to make sure the model is stable and the performance of the model is robust as well. And on top of everything I just described, we also use a lasso model, which is a machine learning model, to make sure that we'll be able to have a relevant benchmarking model to consistently measure the accuracy of the model we deploy to production. So the KYC is not the KYC in the past, but now we're really trying to put different components from the machine learning perspective to make our KYC program more efficient and more effective.
Interesting. So Jessica, with that, are you able to start to have sort of continuous updates to your KYC risk ratings?
That's absolutely right. So we actually build out the ongoing monitoring framework. So on a monthly basis, we build different KPIs and KRIs to ensure that our model is actually performing as expected. So we also set up the different thresholds in case there's a breach. We will have the corresponding action plans to respond to that. So sometimes maybe you just had some thresholds. That means we may have it's necessary for us to recalibrate the model. So we just set up the different thresholds to measure the performance of the KYC, the client risk rating model, on the ongoing basis.
Interesting. Yeah. Now, have you implemented this? Are you still in test? Are you running it in parallel? Or
it's already in production.
Full production.
It's already in production. Full
excellent.
production mode.
Nice.
And we also set up the ongoing monitoring framework is also in production.
Excellent. Yeah. And so have you had to go through any examiner or regulator discussions? How's that gone?
Yeah, so the model has been validated by our model risk management, which is a dedicated function to evaluate, assess, and validate all the models which has been used in SGUS, Société Générale for the Americas. So the model is fully validated, and also we present it to the regulators, but they are relying on the validation results from our risk department.
Oh, excellent. Excellent. So that's a great use case because it really shows how you can use machine learning technology to have more of a continuous update rather than, some of the time boxed and event driven updates that have been happening in the past. And that's one of the key aspects. We've got a couple slides here, which I'm going to go through really quickly because they're nowhere near as interesting as the real world example that you're just talking about, but historically sort of KYC and customer risk rating has been driven by, hey, we'll do these high risk customers every year, low risk customers every 5 years or something like that. And instead what you've moved to is that real time interaction with transaction data, external data, and really letting the events themselves drive changes to customer risk rating instead of just the passage of time.
Yeah.
So that's the first example on KYC. Why don't we move from there into alert scoring for transaction monitoring? And I know this is another area where you've been very active in bringing together historical investigation data to be able to assign scores and bucket alerts into a group that seems very likely or maybe even 100% potential for going into no further action versus those that require further review and further investigation. And there's a lot of good history in terms of being able to gather information, look at things both in terms of the transaction activity, the alerts. The combination of alerts is one of the things that when we did this recently in a test case, we found that it was that rule combination that told us more about things actually than any rule on its own. So we've got a couple slides here that talk about how you can use probability scoring from historical cases, come up with different model features, and then apply that against apply your scoring model against new cases and come up with a predicted outcome. And I think one of the real keys there when we were looking at it was to make sure that the predictive model captured anything that was going into auto NFA. You had kind of 100% clarity there, and you weren't sneaking any of those, anything that we describe as a blue, which was a potential escalation, or a red, which is a true escalation. But those all went into the standard review process. Even if you captured some of the NFAs, that was acceptable, because you didn't want to auto NFA any of those. And we did this with a test volume, a large population of 3 years of investigation results, and we're able to accurately predict 40% of the volume into an NFA bucket. And I know you've done some stuff similar to this that you might want to talk about as well.
Yeah, absolutely. So we build a similar model like this, the scoring model based on the review results. So it's a supervised machine learning model, but in terms of execution, so we still review 100% of all the alerts for now. So we deploy that to production. So basically what we are doing is really to prioritize the review queue. So we are sending the more risky alerts to the more senior analysts, the more senior investigators, while we are sending the less risky alerts identified by the supervised machine learning model to the more junior analysts and more junior investigators. So, I mean, the bottom line is, so basically we use the scoring model to prioritize the review queue.
Yeah. Yeah, and it sounds like you're taking a very conservative approach to that, of never closing anything in an automated fashion, because there certainly is, I think, a supportable argument that after you go through that testing period, you could decide that you were going to auto close those. And, obviously you could continue and probably should continue to investigate a sample of them, just to make sure that the model is working correctly. And there's, I think financial institutions and banks are going to look at this and have a different, the risk appetite will vary depending on financial institution, and some of them will parallel process. Some will do it for a period of time, whether it's 6 months, a year, whatever. But it is definitely a way, and this isn't necessarily to say I'm going to pay less attention to the alerts that I'm generating. It's that you're going to focus the attention of these valuable resources on the alerts that really represent risk to the organization.
Yeah, that's exactly right.
Okay, so this is an area, again, that provides great opportunity to bring in internal and external attributes, to learn from the history of the organization, and to really have something that's customized to the experience of each individual financial institution, and to really build a solid case which can be discussed internally with your model risk management, with your compliance team, with your internal audit team, and then externally with regulators. We've had these types of discussions, both of us, with current and former regulators. One of the keys to these types of activities is always to start those discussions with your regulator early. Don't, get all the way through an implementation and then start talking to them about it. Nobody likes a surprise, especially not regulators. But if you take them along the journey with you and explain exactly what you're doing, show the sampling that you're doing, show the test validation that you're doing, I think there's a lot of acceptance of this type of approach. Okay, I think the next area that we thought would be interesting, I think you've been doing some really interesting things with quality assurance and machine learning that I think people would love to hear about.
Yeah, absolutely. So for the compliance and risk assessment and also financial crime risk assessment, so now we are hoping to see how we can make, the quality assurance more effective, because in the traditional way of conducting a QA, it's really a very manual process, right? We try to identify any human errors, but now we're hoping to see how can we use machine to try to leverage the knowledge and identify those human errors and the inconsistencies in a more efficient way. So basically what we have developed in-house is to build those QA scripts, which can utilize natural language processing, the NLP, to try to identify the inconsistencies that can be identified in compliance risk assessment and the financial crime risk assessment. For instance, if the rating for a particular control is marked as satisfactory, but if then we go to the narratives and the commentary, but we find something otherwise, and then so our machine will be smart enough to identify that inconsistency, to identify this potential human error. In the meantime, we try to identify to see if the commentary is a simple copy-paste error coming from the last year, right? So as I mentioned in the second bullet point, it can be even measured by the percentage of similarity. We just cross-checking all the different input and different entries to try to identify those inconsistency and potential human issues, human errors. So that's what we have done here. We worked very closely with the QA team to try to identify those typologies. Then we built into this QA script. And currently the QA script is already embedded and integrated in the CRA, compliance risk assessment, and FCRA, financial crime risk assessment process. And so in the real time, and so our financial crime risk assessment team will be able to see what potential human errors then can be identified.
So are you applying this across sort of sanction screening and transaction monitoring write-ups and the assessments being produced by the investigations units?
So that's our next step. So right now is the build in the financial crime and compliance risk assessment, because we actually build a risk assessment tool, right, where we are trying to capture all the user inputs and all the risk rating. But I mean, the same idea can be applied to the financial crime transaction monitoring tool as well. So that's actually our plan for the next year.
Okay. Interesting. Yeah, I just finished a long discussion with a client about that was looking at the amount of QA time that is generally allocated in a compliance environment. And, there's that tension between people who are looking at things from a Lean Six Sigma approach and saying multiple touches. Actually, there are a large number of studies that show the more times that anything is touched by a human, the greater the error rate is.
Right.
Because everybody says, a team leader says, well, yes, I'm reviewing it, but QA is going to look at these as well. So there's a relaxed approach to it. And manufacturing has spent plenty of time determining that actually less QA leads to higher quality. But when we're on the compliance side, we don't necessarily have that same freedom. We need to do a certain level of QA because of the compliance nature of what we're doing. So I think the opportunity to introduce something like this that gives us the coverage that we need from a completeness perspective, but also starts to build in some of that efficiency that some other industries have had is very exciting.
That's exactly right. It's not just even the efficiency and also the coverage, because right now the QA is based on sample, right? So you can only QA 10%, 15%, 20%, right? It's a ratio. But when we use a QA script, we use a machine to do the QA, so we can actually QA 100%. So that's what we're doing. So I think completely increased and enhanced the coverage as well. then we can just make the machine work, just leave machine there, as long as we can build a very sufficient hypothesis, right? And cover the different scenarios our QA experts were looking at, and we can build that knowledge to the machine, so machine can execute the QA function for us.
Yeah. And then you can, as you say, you're doing 100%. So all of the information that Tim produces out there, every one of the write-ups or the closures or the escalations gets reviewed to make sure that Tim's doing this on a consistent basis and not changing statuses or, depending on whether it's a good day or a bad day or rushing through things or not, taking too much time on something that's not important.
Exactly. And also we can QA based on your own performance, right? So your today versus your prior days. We can QA across a different analyst, right? So for instance, giving this risk rating, this is a narrative you provided. Let's look at the analyst number 2, Jessica, right? So that's the rating where escalation, where closed alerts. This is a decision she made. What's the corresponding narrative she provided? So we'll be able to cross-checking as well. We can do in parallel, or we can do compare to yourself and compare to your peers.
Oh, that's exciting. That is exciting. Looking forward to.
I feel the same way.
Yeah, look forward to hearing more about that as you continue to integrate that.
Absolutely.
Okay. All right. Well, we had I think one more slide here that we wanted to cover from going back to the survey, and again, this was actually encouraging. I thought. In terms of the results that we got here, that the number one response for the benefits that the organization is realizing is reduced risk. And I think you saw that from the real world examples that Jessica was talking about. They're all reducing risk. So while efficiency gains come along, that's a secondary factor as opposed to the primary factor of risk reduction. And I, for one, was very encouraged by this response because we hear so much about using machine learning to increase efficiency, reduce bodies, cut costs, and that type of thing. But that really isn't the primary role when you're talking about compliance and financial crime. Here, we're trying to reduce risk, and with this, the third response there in terms of being able to better detect financial crime. And really use it in those ways. So Jessica, I don't know if you had any additional comments on some of these responses that we're getting from people across the globe as they think about using machine learning.
Yeah, I think you are actually spot on. Really, I think the number one is really to reduce the risk, right? To make sure our compliance program is as effective as possible. In the meantime, as a scoring model, you demonstrated earlier, it's really 100%. We are trying to cut the false positives, meaning that we're trying to make the program more efficient as well, on top of being more effective. So I really feel the AI will be the future for compliance.
Yeah. Okay. Well, those are a couple of real world examples of where machine learning is being used today in organizations. So I think that it really does show that there's great possibilities out there, great opportunities for anyone that's ready to take that jump. So thank you for your time. It's been a pleasure talking to you today. Jessica, thank you.
Thank you so much for having me here. Thank you. Have a good night.
Good night.